Hi student, I show you again my name, and if you have any question, you can contact me through my WhatsApp, or you drop your question into my mailbox. As you have watched the previous video, the briefing video, the introduction of our syllabus, you know that there are 3 sections in first chapter. This is the first section, graph and models. In this section, we have 4 objectives. In the first objective, you will learn how to sketch the graph of an equation. Second objective, find the intercepts of a graph. That's a graph for symmetry with respect to an axis and the origin. And the last objective, find the points of intersection between two graphs. Make sure at the end of this section, you meet all the objectives. We start with the first objective. Let's say you have one equation, 3x plus y equal to 7. We say this point, 2, 1, is a solution point because when we substitute 2 into the x variable and 1 into the y variable, so where we have 3 times 2, 6, plus 1 equal to 7. So that is why we say this point is a solution point. And this equation has many other solutions. Okay, for example, 1, 4, and 0, 7. Okay, now we test the first point. 1, you substitute into the x variable here, and the 4 into the y variable. So we have 3 times 1, 3, plus 4. Okay, produce 7. So we say this point is a solution point. Okay, and student, you can verify whether this second point is a solution point or not. To find other solution, systematically solve the original equation for y. Okay, so this is a y equation. How to obtain the y equation? So from the original equation, we keep y at left side and constant and x variable at right side. Okay, so this is the first step to get y equation. For second step, construct a table. Then you set the domain. Okay, the example here show you the domain from 0 to 4. I encourage all of you to set your domain from negative value to positive value. For example, you can have your domain from negative 4 to positive 4. Okay, so let's continue our example. Okay, so recall back our first step. We obtain y equation. So our y equal to 7 minus 3x. Okay, so now you take the first value, substitute into the y equation. Okay, substitute into the x variable. So 7 minus 0 equal to 7. And for the second value of x, substitute the 1 into x variable. 7 minus 3, so 4. And you calculate out the value of y according to the value of x, 2, 3, 4. After you came out the value of y, you can verify the solution you obtain here from the table whether correct or not. So we take some of the of the point to verify. Okay, so take the first point. Okay, 0 and 7. Okay, 0, 7. You substitute the 0 and 7 into the original equation. Okay, so 3 times 0, 0 plus 7, so it's equal to 7. So the first one is correct. Okay, and the last point. Okay, we try to take the last point. Okay, 4, negative 5. So 4 you substitute here. So we have 3 times 4, 12. Then plus negative 5. So equal to 7. Okay, so meaning that the last point is correct. Okay, so once we finish our second step, okay, we proceed to third step. Okay, so based on the solution you obtain from your second step, you plot on graph. So here are the solution you obtain. Okay, then you connect, okay, for all the points here, then you form a straight line, because this is a linear equation where the order of x is 1. In your graph, you should have x as this label, y as this label, and equation name. Now we look at the first example. The question asks you to sketch the graph of y equal to x squared minus 2. Okay, so you look at this equation. It's already in y equation, so you can skip the first step. Okay, so we construct a table. Okay, this is the second step. Okay, as I say, I prefer all of you to have domain from negative value to positive value. So you can start from negative 2 to positive 3. Okay, and use the same method. Okay, you substitute the negative 2 into the y equation. So negative 2 squared will be 4. Positive 4 minus 2, 2. And minus 1, you substitute into the y equation. So negative 1 squared positive 1 minus 2 negative 1. Okay, and you complete, okay, the value of y, okay, according to the value of x here. Okay, after you completed this table, you can proceed to the third step. Okay, so you plot your point on graph. Okay, then you connect. Okay, then you form a quadratic graph, and we also can call a parabola. Okay, again I remind you, in your graph you should have x as this label, y as this label, and equation name. We move on to second objective. Two types of solution points that are especially useful in graphing an equation are those having 0 as their x or y coordinate. Okay, so we have two types. So either 0 on x coordinate or y coordinate. Such points are called intercepts because they are the point at which the graph intersects the x or y axis. Now we consider this point, a is 0. A is any constant. Okay, and you can see the 0 is on y coordinate. Okay, so we say this point is an x-intercept. To find the x-intercepts of a graph, let y be 0 and solve the equation for x. Okay, so here, this is a step. Let y go 0 and solve for x. Okay, to get the x-intercept. Okay, so now we look at the second point. Okay, so the point 0, b. B is any constant. Okay, so here now this is a 0 on x coordinate. Okay, so this point is a y-intercept. So to find the y-intercept of a graph, let x equal to 0. Then solve the equation for y. Here are some of the possibilities of intersects of a graph. In first diagram, the curve has no x-intercept, but one y-intercept. For second diagram, there are 3 x-intercepts, 1, 2, 3, and 1 y-intercept. Okay, so the point at origin can be counted as x-intercept and y-intercept. Okay, for the next diagram, okay, there is 1 x-intercept and 2 y-intercept. Okay, for the last diagram, this is a circle. There's no intercept for x as well as for y. Okay, now we look at the second example. Find the x and y intercepts of the graph y equal to x cubed minus 4x. Do you still remember how to get the x and y intercept? To find the x-intercept, let y equal to 0 and solve for x. Okay, so here, we let y, okay, equal to 0. Okay, so equal to 0. Then you solve for y. So look at this equation. We can factorize out the x. Okay, after we factorize, then you solve for x. Okay, so there are 3 values of x. Okay, so you can write the x-intercept. So there are the points. Okay, the next question. To find the y-intercept, let x equal to 0. So when you let x equal to 0, your y equal to 0. Okay, so this is a y-intercept. So this point represents y-intercept. Okay, so meaning that this curve has 3 x-intercept and 1 y-intercept. Okay, you can scale the graph to support your answer. Okay, so here is the graph. Okay, so based on the graph, you can see, okay, there are 3 x-intercept, 1, 2, 3, and 1 y-intercept. Again and again, I remind you, you should have label x axis, y axis, and equation name. The next objective. This slide is telling you why you need to learn the symmetry. Because you just need to know the half side of the graph. Then you're able to scale the other side of the graph. And we have 3 types of the symmetry can be used to help sketch the graph. This is the first type, symmetry with respect to the y-axis. For example, we have a point xy here, okay, and the other point negative xy here on the same graph, so we can conclude this graph is symmetry with respect to the y-axis. Okay, and you also can say that, okay, the portion, okay, this area is a mirror image of the portion to the right of the y-axis here. Okay, or you can say you can treat the y-axis as a mirror. This is a second type, symmetry with respect to the x-axis. Now we have a first point xy and the second point x negative y. Both is on the same curve. So we can conclude this curve is symmetry with respect to the x-axis. And you can treat this x-axis as a mirror. The last type, symmetry with respect to the origin. Okay, let's say you have xy point here, and the second point, negative x, negative y. So both on the same curve. This means that the graph is unchanged by a rotation of 180 degrees about the origin. You can say if you want to move the first point here, this point, to this point, you need to rotate about 180 degrees. This is a guideline to test the symmetry. If you want to test for the symmetry with respect to y-axis, you need to replace x by negative x and then produce the original equation. If you want to test for the symmetry with respect to the x-axis, you need to replace y by negative y and then should produce the original equation. If you want to test for symmetry with respect to the origin, you need to replace the x by negative x and y by negative y, and then must produce the original equation. We can say the graph of a polynomial has symmetry with respect to the y-axis when each term has an even exponent. So look at the example. Okay, we have power 4, power 2, and power 0. Then, same for the graph of a polynomial has symmetry with respect to the origin if each term has an odd exponent. For this example, how are you going to test the graph for symmetry with respect to the y-axis and the origin? Okay, we have a guideline just now. Okay, to test for the y-axis. So, first step, you write the original equation. And the second step, replace x by negative x. And then you simplify. And then you see. You produce the equation that's not same as original equation. So, you can conclude your answer. The graph is not symmetry with respect to the y-axis. Okay, next to test for the origin. First, again, you write down the original equation and you replace the x by negative x and y by negative y, and you simplify. Again, then you see your last equation same as the original equation. So you can conclude your conclusion. The graph is symmetry with respect to the origin. And you can scale up the graph and you can see. So this is a cubic function of the equation. Okay, and then this is a point 1, 1, and the second point negative 1, negative 1. The last objective. A point of intersection of the graph of two equations is a point that satisfies both equations. And you can find the points of intersection of two graphs by solving their equations simultaneously. Look at this example. Find all points of intersection of the graph of x squared minus y equal to 3 and x minus y equal to 1. You can use the graphical method where you have learned in your first objective. You construct a table, then you calculate the output of y for both equations, then you sketch on the same diagram. Then you will find that there are 2 points of intersection, 2, 1 and negative 1, negative 2. However, you can find the points of intersection by using the analytical method. Solve first equation for y and solve second equation for y. Then equal these two equations and move the x and negative 1 to left side, and so that you form general form. You factorize this equation and you solve this equation for x. After you obtain the x value, you can substitute into either the two given equations to produce the y value. Lastly, 2 points of intersection are obtained.